Alright, this is the answer key for the purple worksheet, question number 1. So this says that we have a rifle aimed horizontally at shoulder height, which is about 1.5 meters above the ground, at a target bullseye that's 700 meters away. Bullet's going to leave the barrel with a muzzle velocity of 1,000 meters per second, and we are asked to figure out if it reaches the target, and if it does, where on the target does it hit, and if not, where on the ground is it going to hit. So as far as information goes, we have to set up our XY table. So based on our XY table, X's are always the same, so we're going to have a delta X, a VX, and a TX. So for our delta X, I'm going to label this as delta XT. That delta X, for our delta X, I'm going to label this as delta XT. Then that T stands for target, so that's going to tell us that we potentially have a displacement of 700. We are going to have a velocity in the x direction that's given to us in the problem of 1,000 meters per second. And then we have a time in the x direction that we do not know right now. So we're going to have to leave that spot open. Now, problem solving wise, we have to figure out what type of projectile we have. So since it's aimed from shoulder height and it's horizontally launched, that's a height to ground with no angle. So that's going to mean that in terms of y variables that we have, we're going to have our delta y cliff, which is our starting height, but in the negative because it's going to fall down from that height. The initial in the y direction, which is always 0 for horizontally launched projectiles. Time in the y direction, and that's going to be what we're trying to find. Gravity is always negative 9.81. And we could potentially also be tasked to find the v final in the y direction, though for this problem we do not have to. So our goal here, we're trying to figure out if it reaches the target. So the best way to do this is to figure out how far it's actually going to travel. So we're trying to see if the delta x is greater than 700, if it's less than 700, or if it's equal to 700. So depending upon what that information is, that's going to tell us whether or not we hit the target, and then we can solve from there how far we actually will hit said target. So that means that delta x target is just going to be a reference point for us, and we're not even going to worry about it as far as the table goes. So in order to figure out delta x, we need time in the x direction. And time in the x and time in the y for height to ground projectiles with no angle are equivalent. So we're going to have to figure out time y first. And to do that, we should use our free fall equation, which is delta y is 1/2 gt squared. So time down is what we're actually doing, which in this case is actually time y, so 1/2 gty squared. And again, time y and time x are the same, so we just plug in the information that we have. Delta y is negative 1.5, that's equal to 1/2 negative 9.81 time squared. So solving for that value, multiply both sides by 2, divide by gravity, you're going to end up getting a time in the y direction that is going to be 0.55 seconds. So depending on how you round, you could also have 0.553 seconds. The 0.55 is fine, but if you want to take it out one more, also acceptable. So what this tells us is that our projectile is going to be falling 4.55 seconds. So during the time that it's falling, it's also moving forward. So what we want to see is where that forward motion takes us. So is that going to take us to the target? Are we going to be short of the target? Or are we going to go past the target? So we need to check then to see basically where our delta x actually is. So we are going to do so by using the only equation we have for the x direction, which is delta x is vx tx. We have our vx, we have our t, so 1,000 multiplied by the time. And again, depending on if you use 0.55 or 0.553, you're going to get a different value. So officially, you're going to end up with 550 meters. And that 550 meters tells us that our projectile is actually going to land on the ground at 550 meters. So if we looked at that as far as the diagram goes, we would have our arrow, which is shot from our bow. It's at a height of 1.5. Even though it doesn't officially say it, we are assuming that the target is also 1.5 meters high. So we're going to have a distance of 700 from the arrow to the target. And our projectile is actually going to land at a position of 550 meters from start. So as far as our answer goes, it says, does it reach the target? The fact that our delta x is 550 and our target's 700 away answers no. And then our B answer, it says, where does it hit? You could say at 550 meters, because that's technically a reference point. But you could also indicate how short it is from the target itself. So we could say 150 meters short.